Now we're going to apply our special triangles specifically to trigonometry. But let's first remind ourselves of the trig ratios that you learned in geometry. Let's say we have an angle theta in a right triangle. The side opposite theta is this side here. I'm going to abbreviate opposite. That's the opposite side. The side next to theta we call the adjacent side. And then the side opposite the right angle is called the hypotenuse, and which I'm abbreviating HYP. And to find the sine of the angle is taken by the ratio of the opposite side divided by the hypotenuse. Cosine of theta is the adjacent side, the length of the adjacent side divided by the length of the hypotenuse. And tangent of theta is the length of the opposite side divided by the adjacent side. Now some people like to remind themselves of this with a little acronym that uses these letters. SOH-CAH-TOA, sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite over adjacent, SOH-CAH-TOA. Now let's apply this to our right triangles. We learned that if we want to label these right triangles, we can label the 30-degree triangle as 1, hypotenuse is twice as big as the shortest side, 2, and the third side is square root of 3. That's the side opposite the 60-degree angle. We can also orient it the other way, so if we're thinking of 30 being our theta here, and here 60 will be our theta, so we can say square root of 3, 1, and 2 in that order. Now make sure that you don't mix these up. These are the ones that people tend to mix up the most. Remember that 1 squared plus the square root of 3 squared has to equal 2 squared, which it does. 1 plus 3 is equal to 4. Check. So if for some reason you get that mixed up, then your Pythagorean theorem won't work. So that's a good check if you're not sure. Then our 45, 45, opposite both 45-degree angles, it's 1, and then this is the square root of 2. And once again, 1 squared plus 1 squared is equal to c squared. So 2 is equal to c squared. So the square root of c, or c has to equal the square root of 2. So that's where you get that third side. Now, let's apply the ratios that we see that are abbreviated SOH-CAH-TOA to these different angles. So sine of 30, which is also the same as sine of pi over 6, since 30 is 1/6 of 180 and 180 equals pi. Remember that, 180 equals pi. So sine of 30 is opposite, the side opposite 30 divided by the side adjacent to 30, or 1/2. Cosine, side, I said that wrong. I'm sorry. The side opposite 30 to the hypotenuse. That is sine. For cosine, side adjacent divided by hypotenuse. Square root of 3 over 2. Tangent, opposite over adjacent, which is 1 over the square root of 3. But I'm going to rationalize the denominator by multiplying numerator and denominator by square root of 3 over 3. So square root of 3 squared is just 3. So this is square root of 3 over 3. Okay, go to sine of 60. Now 60 is the opposite over the adjacent, so now it's square root of 3 over 2. Cosine of 60 is 1/2, adjacent over hypotenuse. And tangent of 60 is opposite over adjacent, or square root of 3 over 1, which is just square root of 3. Now looking at 45, opposite over hypotenuse and adjacent over hypotenuse are the same number. They're both 1 over the square root of 2. Remember, we can multiply that by square root of 2 over square root of 2, which gives us square root of 2 over 2. That is square root of 2 over 2 for both sine and cosine. Tangent is 1 over 1, which is just 1. Okay, so those are our trig ratios for our special angles. So tangent of pi over 4. Now, we're going to learn how to apply this to all the other special angles that we learned about, but this is kind of our starting point, and I wanted you to see this as kind of the basis of what we're going to be doing with the unit circle.